Hello everybody, and welcome to our class video about composite surface area and volume. Our learning goal is that you'll be able to determine the surface area and volume of a three-dimensional composite figure. We've done composite areas before, but just in case you don't remember what that word composite means, it means that it's composed of two or more basic shapes. See how the word composed and composite are similar to one another? Okay, so it's made up of two or more shapes, like it could be a prism and a cylinder, or a cylinder and a cone, or a cone and a sphere, or whatever. Okay, so let's take a look at a few examples. So let's find the volume of the composite figure below. Okay, we're starting with a volume question because volumes of composite figures tend to be a little easier or less complex than surface area questions. Alright, so the first step in any of these type of questions is to recognize what kinds of three-dimensional figures we have. In this case, we have a cube and we have a cylinder that's been cut out of the cube. Okay, so the next step would be to write a plan to find that volume. Now for this one, it's relatively simple, so it's not, you wouldn't necessarily have to write one, but I want you to have this tool in your tool belt for when you get to more complex type of shapes. Okay, so in this case, I would need to find the volume of the cube, and then we'd need to subtract from it the volume of the cylinder. Okay, that equation right there represents my plan. I'm going to take the volume of the cube and subtract the volume of the cylinder. Okay, so having our plan, we can go ahead and find the individual pieces that we need. So to get the volume of the cube, a cube is a type of prism, so we'll use the Prism formula. That's area of the base times height. So the area of the base, which would be right there, would be 64 square feet. And the height would be 8 feet. So if I multiply those together, I get 512 feet cubed. Because feet squared times feet is feet cubed. That's the units we should have. Okay. Alright, now we can get the volume of the cylinder. That formula is pi r squared h. So we've got a radius of 4, because that's half the diameter, which is 8. Then the height of the cylinder, which is 8. If I multiply those together, I'll get 402.124 cubic feet. So, now that I have those two numbers, we can execute our plan. So, that's 512 minus 402.124, and that leaves me with 109.876 cubic feet. That would be the volume of our figure. Alright, that wasn't too bad, right? Now let's do a surface area example. These tend to be a little bit more complicated, but we can do it. We still start with recognizing what three-dimensional figures we have. So in this case, we have a cone sitting on top of a rectangular prism. Step 2, we again are going to write a plan to find that total exposed surface area. That word exposed here, although not necessary for the sentence, is pointing to a key principle that we need to pay attention to, which is, if you can touch it, you must include it. So when I'm finding the surface area, I need to include all of the areas that are on the surface. Okay, and if it's on the surface, I can touch it. So if you can imagine that you could touch that part of the object, then that area must be included in the surface area. And similarly, if you can't touch it, then that would not be included in the surface area. Alright, so let's use that to help us create our plan. We can start with the surface area of the prism. That would include the bottom of the figure, it would include all of the lateral sides, and it would also include the top. So we've covered all of the surfaces of the prism by that one formula. However, can I touch all the parts of the prism? No, I can't. Because I can't touch anything that is below the base of the cone. Okay? So, because I can't touch that, I need to exclude it. So I need to subtract the area of that circle. Okay? So if I remove that, then I still have covered all of the surfaces of the prism, while still leaving those corners on the top intact. Okay, so then what's the final surface we need to include? That would be the lateral area of the cone. We're not including the bottom, so that's why we would want the lateral area, because that would just include the sides of the cone, which is here. Now, there's multiple ways to do this. So it's possible also to write a plan like this: the surface area of the prism plus the surface area of the cone, the total surface area, which would include the bottom, and then subtract 2 circles, because you included it once for the cone and once for the prism. Now that just sounds like more work to me, so we're not going to go that way. Alright, so let's calculate the individual pieces then. So the surface area of the prism would follow the formula pH plus 2b. So the perimeter of the base, which is P, would be 4 plus 4 plus 4 plus 4, which is 16. Then the height of the prism is 2. And the area of the base would be 4 times 4, which would be 16 meters squared. Okay, notice that the P and B are both numerically 16, but they have different units. But when I multiply each of those pieces out, both sets are going to have meters squared, so I'm going to end up with 64 meters squared as the final result. Okay, so that's the prism. Then I need to subtract the area of a circle, so that would be pi r squared. The radius of the cone is 2, so that would be 12.566 meters squared. Now notice that I use 3 decimal places here, and I can actually keep more in my calculator because I've been showing you guys how to use the answer button on your calculator. Okay, even though the directions say round to the nearest tenth. So you don't want to round until you get to the very end of the question, because the more times you round, the more your final answer will be off. So I'm going to keep more decimal places. I'm going to keep 3 decimal places here. I mean, I don't want to write down all of them in the calculator, but I'm going to use all of them in the calculator and use the answer button to carry forward what I need. Okay? So don't round to the very end. And we need to get the lateral area of the cone, so that's pi RL. The radius again is 2. The slant height is already given to us on the figure, how nice of them, and it's 4. Okay, so if I multiply those, I'll get 25.133 meters squared. Again, notice I'm not rounding to the 10th yet. Okay, if I follow the plan now, I would use 64 meters squared for the prism, minus the area of the circle, plus the lateral area of the cone, using all the decimal places in the calculator, and I'm going to get 76.5664 meters squared. Okay, now since I've gotten to the end of the question, I want to round to the nearest tenth. So I'll use this 6, which is in the hundredths place, to round up the 5, which is in the tenths place, to be 76.6 meters squared. Alright, well that was kind of a long question, but I know you guys could do ones like this. So we'll do some more practice in class. Alright, I'll see you guys later.